Hello everyone. So today's topic is big data and cloud analysis. So we are going to dive into a um, topic that has become a cornerstone of modern technology and business, which is big data and cloud analysis. As many of you may already know, data is often referred to as the new oil in today's digital economy. With the vast amounts of data being generated every second from social media interactions to IoT devices and business transactions, the ability to manage, analyze, and extract insights from this data has never been more crucial. This is where big data comes into play. However, managing such enormous volumes of data requires resources and infrastructure that traditional systems simply cannot handle. Um, Enter the cloud. Cloud computing provides scalable and flexible and also cost effective solutions that empower us to harness the power of big data. So, in this session, we'll explore how big data and cloud technologies work together, transforming raw data into actionable insights and driving innovation across industries. So, um, let's see the overview of the lecture. We'll start with a foundational understanding of what big data is, looking at how and why it has become an essential asset in today's digital world. Next, we'll examine the defining features of big data, often referred to as the 4Vs: volume, velocity, variety, and veracity, that make it both powerful and challenging to manage. Then we'll explore the technologies developed to handle big data, such as Hadoop, Spark, and others that enable organizations to process and analyze massive datasets effectively. Moving into the cloud side of things, this section will cover the basics of cloud computing, its architecture, and how it provides a scalable solution for data storage and processing. Here, for benefits of cloud, we'll discuss why the cloud is such a perfect match for big data, focusing on scalability, flexibility, and cost effectiveness that cloud platforms offer for managing large data sets. We'll then look at specific cloud platforms like AWS, Google Cloud, and Microsoft Azure that provide tools and services specifically designed for big data analytics. Finally, we'll wrap up with a real world case study demonstrating how big data and cloud technologies are used together in practice, providing insights into the practical applications and benefits. So, okay, now in this section, we are going to lay the groundwork by understanding what big data really is and why it becomes so significant. Firstly, let's define big data. Essentially, big data refers to data sets that are so large and complex that traditional data processing software finds it difficult to manage them efficiently. These aren't just your average data sets, they are vast and constantly growing, and it requires specialized tools and strategies to process. Now, why big data is so important? For businesses and organizations, big data is a valuable asset. So, by analyzing these large data sets, companies can gain deeper insights, make more informed decisions, and optimize their processes. This ability to understand trends, patterns and even predict future behaviors can provide a competitive edge. Then finally, let's consider where this data comes from. These are multiple sources, including social media platforms, which generate vast amounts of user data daily. Then IoT devices, which provide real time data from sensors and connected objects, and transactional data from customer interactions, purchases, and more. So, together, these sources contribute to the growing landscape of big data. So, understanding big data's definition is important because it is very important nowadays, and sources helps us appreciate the scale and impact it has on today's digital world. So now that we have an understanding of what big data is, let's look at its core characteristics, often referred to as the 5 Bs. So it is actually 5 Bs. I said 4 Bs, I think, for the lecture overview. So each of these elements defines the nature of big data and the unique challenges and opportunities it presents. First is volume. So the first characteristic is the sheer amount of data generated. We are talking about vast quantities. Think petabytes or even exabytes of data. This massive scale requires specialized storage and processing solutions to handle effectively. Then we have variety. So big data comes in various forms, from structured data like tables and databases to unstructured data like images, videos, and text documents. This variety means that data systems must be flexible enough to work with different data formats. Then we have velocity. It refers to the speed at which data is generated and processed. In today's world, data is constantly being created at a high pace, especially with real-time systems such as IoT devices and social media platforms, which demand rapid data handling. Then we have veracity. This aspect addresses the trustworthiness and quality of data. Not all data is accurate or complete, and some can be misleading. Ensuring data veracity means filtering out the noise and keeping reliable information, which is crucial for making accurate decisions. Lastly, we have value. The purpose of collecting and analyzing big data is to extract actionable insights. Value represents the business or social benefits derived from data. Without value, big data would simply be a collection of information without a purpose. So, understanding these characteristics helps us grasp the complexity and the power of big data. Each V brings its own challenges, but together they illustrate why big data requires sophisticated tools and methods to manage effectively. Okay, now that we have explored the characteristics of big data, let's dive into the technologies that make it possible to manage and analyze such massive data sets. These tools and frameworks provide the foundation for big data processing and storage and analysis, helping organizations turn data into actionable insights. First, we have Hadoop, a distributed storage and processing framework. Hadoop allows us to store vast amounts of data across multiple machines, and process it in parallel, making it highly scalable and suitable for handling large data sets. Next, we have Apache Spark. So this is a powerful real-time processing engine for large-scale data. Unlike Hadoop, which processes data in batches, Spark is designed for real-time analytics, which enables faster and more efficient data processing. Third, we have NoSQL databases. For handling unstructured data, we often turn to NoSQL databases like MongoDB and Cassandra. These databases are optimized for flexible schema-less data models, so making them ideal for unstructured and semi-structured data, which is common in big data environments. So lastly, we have data lakes, which are centralized repositories designed to store large volumes of raw data in its native format. Data lakes offer a flexible solution for storing unstructured, semi-structured, and unstructured data, allowing for a more versatile approach to data storage and analysis. So together, these technologies provide the infrastructure needed to store, process, and analyze big data efficiently. They each play a unique role in the big data ecosystem, allowing us to work with data at an unprecedented scale and complexity. So now let's focus on cloud computing, which plays a vital role in enabling big data processing at scale. Now, cloud computing refers to the delivery of various computing services over the internet, including servers, storage, databases, networking, and software. Instead of relying on local servers or personal computers, cloud computing allows businesses and individuals to access resources remotely, often paying only for what they use. So, it is categorized into different models based on the way resources are accessed and managed. First is public cloud. This model provides services over the internet managed by third-party providers like AWS, Microsoft Azure, and Google Cloud. It's scalable and cost-effective, ideal for organizations that don't want to invest heavily in infrastructure. Second, we have private cloud. In a private cloud, services are used exclusively by one organization, providing greater control and security. This model is often preferred by organizations that handle sensitive data or have specific regulatory requirements. Now, lastly, we have hybrid cloud, which is a combination of public and private cloud resources, which allows data and applications to move between the two environments. This approach offers flexibility, enabling organizations to take advantage of the scalability of the public cloud while keeping critical resources secure in a private environment. So, understanding these cloud models is essential as they provide different levels of flexibility, control, and cost effectiveness depending on the organization's need. Now that we have explored cloud computing models, let's discuss the specific benefits that the cloud offers for big data. These benefits address some of the key challenges faced by organizations working with massive data sets. First is scalability, and this is one of the primary advantages of using the cloud for big data and because platforms allow us to easily scale resources up or down depending on the volume of data and processing needs. This flexibility makes it feasible to handle large data sets without worrying about physical infrastructure limitations. Second, it is cost efficiency. Cloud services typically follow a pay-as-you-go model, which means organizations only pay for the resources they use. This model eliminates the need for significant upfront investment in infrastructure, making it more cost effective, especially for businesses that don't need constant high level processing power. Third, we have flexibility. Cloud platforms offer access to a wide range of services and tools tailored for data analytics. From storage options to advanced analytics tools, cloud providers give users the flexibility to choose the services that best fit their needs. So, this flexibility makes it easier to integrate big data workflows with other systems. Now, many cloud platforms support real-time data processing, allowing organizations to analyze and act on the data as it is generated. This capability is especially valuable for applications that require immediate insights like monitoring systems, customer engagement, and IoT applications. So these benefits illustrate why cloud computing is a game changer for big data. It not only takes or makes large scale data processing feasible, but also more efficient and accessible. Now here in this section, we are going to look at some of the major cloud platforms that provide specialized tools and services for big data analytics. Each of these platforms offers a range of resources tailored for handling datasets, enabling organizations to store, process, and analyze data efficiently. So, first is Amazon Web Services, AWS, which is one of the most popular cloud platforms for big data. Some of its key services include AWS S3, which is a highly scalable storage service used to store and retrieve any amount of data. Then Redshift, which is a data warehousing solution optimized for high performance analytics on large data sets. Then EMR, Elastic MapReduce, a cloud native framework for processing vast amounts of data using Hadoop and Spark. Second, we have Microsoft Azure, another leading cloud provider, which offers a variety of tools for big data analytics, such as Azure Synapse Analytics, which is an integrated analytics service that brings together data warehousing and big data processing. Then Data Lake, a storage repository that holds large amounts of raw data in its native format. And then we have HT Insight, which is a fully managed cloud service that makes it easy to process massive amounts of data with popular open source frameworks like Hadoop, Spark, and Kafka. Then we have Google Cloud Platform, which also provides robust solutions for big data with tools designed for both batch and real-time processing. It includes like BigQuery. It is a serverless, highly scalable data warehouse ideal for interactive analysis of large data sets. Dataflow, which is a real-time processing service that supports both batch and stream data processing. Then we have Dataproc, which is very fast, easy to use, fully managed cloud service for running Apache Spark and Hadoop clusters. Each of these platforms has its unique strengths, making them suitable for different types of data workloads and processing needs. Okay, so here let's look at an essential aspect of working with data in the cloud, data integration. So integrating data from multiple sources. In today's data landscape, information is generated from a wide range of sources, including databases, IoT devices, social media, and more. Cloud platforms provide tools to combine these different data streams, allowing us to analyze data in a more unified and comprehensive way. Then ETL, cloud-based ETL. ETL means extract, transform, and load. So ETL is a critical process in data integration. It involves extracting data from various sources, transforming it into a usable format, and loading it into a data repository. Platforms offer ETL services especially designed for big data, which automate and simplify the process of cleaning and preparing data for analysis. These services are scalable, so they can handle both small and large data sets effectively. Now lastly, we have real-time data integration. Many modern applications require real-time data integration to support streaming analytics. So cloud platforms enable this by offering tools that can integrate and process data in real time, allowing organizations to gain immediate insights. This capability is particularly valuable for applications like monitoring systems where timely data processing is crucial. Now let's talk about two fundamental approaches to processing data in the cloud. First is batch processing and real-time processing. Understanding the difference between these two methods is key to selecting the right strategy for different types of data analytics tasks. In batch processing, data is collected and processed in large chunks at scheduled intervals. This approach is ideal for handling large volumes of data that don't require immediate analysis. It's particularly useful for historical data analysis where insights are drawn from data accumulated over time. So, if you for example, processing monthly sales reports or aggregating yearly customer data, you can use batch processing that doesn't require any real-time processing. So next we have real-time processing. Unlike batch processing, real-time processing analyzes data as it's generated, providing immediate insights. This approach is essential for time-sensitive applications where quick responses are necessary. Real-time processing is commonly used in cases such as fraud detection, where rapid analysis can prevent fraudulent transactions, and IoT monitoring, where immediate data from sensors is critical for system health and functionality. So, choosing between batch and real time processing depends on the specific requirements of your case. While batch processing is efficient for periodic analysis, real time processing is invaluable and so it is also important for the applications needing instant feedback. So by understanding these two methods, we can better match our data processing strategies with our business goals. So this is how big data analytics life cycle goes. So which outlines the steps involving transforming raw data into meaningful insights, which we already did from the beginning of our course. We learned about the data collection, data storage, processing, data cleaning, analysis, visualization. We learned all of this from the beginning of our course. So first you have to gather data, then you have to store that data, then you have to process, and then during this processing period you have to clean, transform, and organize the data. Then you have to analyze the data, and then you have to make the visualization for data. Okay, so now let's focus on a critical aspect of working with big data and cloud environments: data governance. In today's data-driven world, having robust data governance practices is essential for ensuring data quality, security, and compliance. So, data governance involves setting up policies and procedures to manage data accuracy, consistency, and security across an organization. With large volumes of data and multiple sources, maintaining data quality can be challenging. So, effective governance ensures that data remains a reliable and trustworthy asset, supporting better decision making. Second is data stewardship. Data stewardship is about assigning roles and responsibilities for managing data assets. This includes identifying individuals or teams responsible for ensuring data quality, handling data access, and maintaining data security. Having clear stewardship roles helps prevent data misuse and ensures accountability within the organization. Then most cloud platforms provide governance tools to monitor data quality, manage access controls, and ensure compliance with regularity standards. These tools enable organizations to maintain visibility and control over their data in the cloud, helping them meet legal and ethical obligations. So now it is important to recognize some of the key challenges involved in managing big data in the cloud. While cloud platforms provide many benefits, they also come with complexities that organizations need to address. One of the primary challenges is ensuring the privacy and security of sensitive data stored in the cloud. So, cloud environments are accessible over the internet, which can expose data to potential threats if not properly secured. Next, integrating data from multiple sources and in various formats can be complex, especially when dealing with structured, unstructured, and semi structured data. Effective data integration requires robust tools and processes to ensure data consistency and quality. Um, Third is cost management. As data grows, so do storage and computing costs. Um, Managing these expenses while maintaining performance and scalability can be a significant challenge, especially for organizations that deal with fluctuating data volumes. Then, fourth is compliance with regulations. Regulations like GDPR, HIPAA, and other data privacy laws impose strict guidelines on how data should be managed, particularly regarding personal information. Ensuring compliance with these regulations is essential to avoid legal issues and maintain customer trust. Um, to address security concerns, organizations use various cloud security tools, um, such as encryption, multi-factor authentication, and cloud security services. However, managing these tools and staying up to date with best practices can be complex and resource intensive. So, each of these challenges highlights the need for a well planned strategy when working with big data in the cloud. By understanding and addressing these issues, organizations can make the most of their cloud based data initiatives while minimizing risks. Okay, now let's look at some of the essential tools. Um, Here we have some tools and technologies that enable big data analytics in the cloud. First is cloud storage solutions, which we already talked about. Amazon S3, which is highly scalable storage service from Amazon AWS. Then Google's cloud storage for large scale data storage. Then Azure Blob Storage, which is designed to handle unstructured data. Then we have data processing engines, which are used to manage and analyze data in large volumes. They allow for fast data processing, which is crucial for big data workloads. So these are some key engines. Apache Spark, which is known for its speed and real-time processing capabilities. Hadoop, which is widely used framework for distributed storage and processing. Google Dataflow, a fully managed processing service from Google, suitable for batch and stream data processing. Then we have data visualization tools, where we have Tableau, which is a powerful tool for interactive data visualization. Then we have Power BI, which is Microsoft's business analytics service, with a focus on integrating with various data sources. Then we have Google Data Studio, which is a free web-based tool for creating interactive dashboards and reports. These tools and technologies from like using these tools and technologies can make a comprehensive toolkit for working with big data in the cloud, from storing and processing large data sets to presenting insights effectively. Okay, so to bring everything together, let's look at a real world example on how cloud based the big data analytics can solve critical business problems. In this case study, we'll examine how a financial services company used real-time analytics in the cloud to enhance their fraud detection processes. So, first, the problem is the company faced a significant challenge. They needed it to detect fraud in real time. Traditional fraud detection methods often take hours or even days to identify suspicious activity, by which time the damage might already be done. So the company needed a faster, more efficient solution to minimize potential losses. Okay, for the solution, to address this, the company leveraged cloud-based tools to collect and process transaction data in real time. They used machine learning models deployed on the cloud to detect anomalies and identify potential fraud as transactions occurred. Cloud platforms provided the necessary scalability and speed for this data intensive task. So the result was a drastic reduction in fraud detection time from hours to minutes. This improvement allowed the company to respond to threats almost immediately, preventing significant financial losses and enhancing overall security. So this case study highlights the power of real-time analytics in the cloud. By combining cloud infrastructure with machine learning, organizations can tackle time-sensitive challenges effectively and make data-driven decisions that protect their assets. It's a great example of how the cloud can transform data analytics into a proactive tool for business resilience. Okay, so now let's see some of the best practices for big data analysis in the cloud. First is one of the key advantage of the cloud is its ability to scale with your data needs. By using cloud services that scale automatically as data grows, organizations can ensure they have the resources needed to process large data sets without overcommitting. This allows for flexibility and helps maintain performance even the data if the data demands fluctuate. So next, security is a top priority when working with sensitive data in the cloud. Best practices include encrypting data both at rest and in transit, and implementing strong access controls to limit who can view and manipulate data. It not only protects against breaches but also supports regulatory compliance. Then focus on cost management. Cloud services are cost effective but only with careful management. It's essential to monitor resources uses and optimize cloud expenses by avoiding over provisioning and using only the necessary resources. So you can customize your cloud services as you need. So now let's look at some emerging trends that are shaping the future of big data and cloud analytics. These developments are set to revolutionize how we handle data, making it more powerful, efficient, and secure. First is machine learning and AI. As big data continues to grow, machine learning and artificial intelligence are playing an increasingly important role. These technologies allow us to derive deeper insights from data by identifying patterns, making predictions, and automating decision making. So, by integrating AI with big data, we can gain more value from data with less manual effort. Edge computing. What is edge computing? It is another significant trend. Instead of processing data in a centralized cloud, edge computing brings computation closer to the data source. This enables real-time analytics as data is processed directly at the edge. So, for example, on IoT devices or local servers, it's particularly useful for applications that require immediate responses, such as autonomous vehicles or industrial automation. Then we can have serverless computing, which is changing how applications are deployed in the cloud. With serverless, developers can run code without worrying about managing infrastructure. This model is cost effective and allows for rapid scaling, making it ideal for big data applications where workload demands can fluctuate. Lastly, we have enhanced security. So, there's a stronger focus on enhancing security in the cloud environments as data privacy concern grows day by day. This includes more advanced encryption methods, multi-factor authentication, and robust access controls. Okay, so in conclusion, we can say we have explored the transformative power of big data and cloud analysis. These tools are essential for modern businesses seeking to gain valuable insights from vast amounts of data, enabling data driven decision making that drives growth and innovation. Um, Cloud platforms offer scalable and cost efficient solutions that make it feasible to store, process, and analyze large data sets. Um, Finally, we looked forward the future of big data and cloud analysis, where advancement of AI, machine learning, and real-time processing will continue to redefine what's possible. So that's all for today's lecture. Let me know if you have any question or concern. Thank you.